we're going to be looking at clocks today. So clocks are a number theory tool that have helped me very much in visually understanding modular systems, remainder systems, that's what that means, and just prime numbers and different types of numbers in general. So let's just get into it. So a clock is basically made by drawing a circle and drawing little tick marks on it that are evenly spaced. So this is right here a clock with 5 numbers. This one has 3, this one has 4, and on another piece of paper I've drawn one with 9. So we're gonna have this little list here. We're gonna define a clock as good if it meets these conditions. So first, let's just pick a number to start with. We'll just start with 1. So we're gonna define skipping as going over a number. So if I skip 0 numbers, then I go from 1 to the next number. So that's 2. So I go from 1 to 2, skipping no numbers in between. Then I go straight to 3. I go straight to 4. I go straight to 5. And I go straight back to 1, hitting each number exactly once. So that forms a perfect pentagon. Now if I skip one number, that means I skip over 2 and I go straight to 3. Then I skip over 4 and go straight to 5. Then I skip over 1 and go straight to 2. Then I skip over 3 and go straight to 4. I skip over 5 and go straight to 1. I form a perfect star. And I could skip over 2 numbers, but I'm going to end up making my star again because of how the symmetry of these clocks are. So on all the odd numbered clocks, if you just draw a vertical line down, you only have to test the cases on this side of the vertical line, because if you start testing these cases, you're going to get the same ones. So that means that this clock is good because I drew I was able to connect all the points by skipping 0 and skipping 1, because I don't need to skip 2 and so on. So that means that I can add the number 5 to my list of good clocks. Let's test if 3 is good. So that means that let's draw my vertical line. So I only need to test the case where I'm going to skip 0. So I go straight from 1 to 2, skipping nothing. Going from 2 to 3, skipping nothing. Going from 3 back to 1. And this is very bad spacing, but that should be equilateral triangle. So 3 also is good. So you might be thinking, odd numbers are good. Let's see if even numbers are good. So on my clock of 4, I'm going to go from 1 straight to 2, skipping 0. I'm going to go 2 to 3, go from 3 to 4, go from 4 to 1. So that's fine because it hits all the numbers. Now if I skip 1, I go from 1 to 3. Then I go down, and then I skip 2, and I skip 1, I go back up to 1. Then it forms an infinite cycle between 1 and 3, and 2 and 4 have no chance of getting hit at all. That means that the clock with 4 is bad because we can't satisfy all the conditions. So that's bad. And you're going to see that any even number is bad because an even number always has one case at least where you go from here to here and just keeps forming that vertical line. So we can generalize and say all evens. But this is not necessarily true because let's just take the case where there's one even number that does work, and that even number is 2. So it's like a very simple case. I put 1 at the top, 1 at the bottom, and if my only choice is to skip 0, so I can just go straight down. And even though it forms an infinite vertical line, notice there's no other points to hit, so the condition is satisfied. So you might be starting to see the certain numbers that do work. So 2 is the only even number, also the case in prime numbers. And will all the odd numbers work? Let's just test the last case with 9. Notice with 9, if we skip 0, it'll work. It'll just form a regular nonagon. If we skip 1, it'll also work. So let's just see that really fast. So skipping around, skipping around, skip here, skip up, and perfect. So all of them are hit. But you're going to notice that if you skip 2, something goes wrong. So if I skip 2, that means I go from 1 to 4. I go from 4 to 7, and I go from 7 back to 1. And that forms an equilateral triangle, which is going to be infinite. It's going to keep going, and no other points will get hit. And that occurs because 3 is a factor of 9. Because when I go 1/3 of the arc, 1/3, it's going to go infinite. That's the same reason that happened in the circle with 4 points. So we're going to see that clocks work for all prime numbers, since they don't have any factors, and clocks don't work for all composite numbers. And this is going to help you a lot in number theory. We'll be using this again and again to visualize a lot of things.